Regarding the performance of the plot and manipulate function, options like performance goal can be quite handy. For instance, I'm going to show you a manipulate example, and we can have manipulate, then we have plot 3D, which will graph sine of axy square brackets axy, and the x will have values from -2 to 2, and the same goes for y, which will have values from -2 to 2. Now we can specify the values for the a, which will be our controller, and will go from 1 to 5. If we try manipulating the controller up and down, we get the simplified view, which is a Mathematica's way to improve performance and make it better, make it faster and better for these dynamic changes to take effect. We can prevent that by adding performance goal to the plot 3D itself. So we can say performance goal speed, in which case when we change the values, not the speed is the opposite. In fact, we can change it to quality, in which case we constantly get this beautiful graph which practically looks like a blanket, and this is practically the way you get it done. Another thing we can do is labeling controllers. That is, we don't really see the values beside the a, right? And we don't really see what the value or what the a is. That is, we can't name it something beside a. And to achieve that, if we want to have, let's say, amplitude instead of a, all we have to do is put a pair of curly braces right there instead of a in this controller parameter. First parameter is a, then we have default value of 1, and then you label it as, let's say, amplitude. And as a result, we get it. Another useful thing that we can do is we can make it so the values of the controllers are displayed right beside them. That is, for instance, we have this amplitude and we want it to be labeled, and for that to be the case, we have to change appearance and make it labeled, in which case we start seeing the small digit right there that changes. What if we want to label the plot and call it something? In that case, this is very simple. All we have to do is get to this plot 3D, and then we can label the plot as whatever we want. For instance, a graph of mine. And as a result, we get the label right there. It works just like that with usual plot, where you can plot it from 1 to 10, and then you can say, I'd like to change the plot label, and we can say part of quadratic equation, and we'll get the label right there. How do we put one of the controller values into that plot label if we want to? Well, we can again start with manipulate, and we can create a simple plot. just like that. That will have sine as its value, f multiplied by x plus ps. Now we can graph it from x that goes from 0 to 2 pi. Then we can add a label to it. We should probably add later, so let's define the controllers first. That is, we have the first controller, second controller for f and ps, and inside of this we'll have f controller with default value of 1 with the name of frequency. Then the controller will have a range from 1 to 5, and it will have the numbers visible, the value it has, which we'll say labeled. We want the same absolute case scenario with slightly different values for the ps variable, just like here. And we will call it phase shift. It will go from 1 to 6 and also be labeled. As a result, we get this beautiful graph which we can manipulate whatever way we want. Now, regarding the label, how do we add a label to that plot that has values of the controllers in it? In order to do that, you just have to define sine. Let's do a simple example first. There we see it, sine, right there. Now, in order to add strings together, all we have to do is input an arrow that looks to the right and left together, and then we have to specify another string which we want to add. In my case, of course, we want to take one of the controller values f, convert it to string with this toString function, and then add it to x plus, then add another string which is a toString from ps, and at the end we want to add a parenthesis, and as a result we get a label that is constantly changing, just like that. This is it.